Wind Turbines by Sam Bynum, Daniel Huffines, and Phoenix Lopez. Throughout this presentation, we will point out the design criteria which help make this operation successful. We will also discuss their impact environmentally, economically, as well as take a look at them from a global perspective. So what are wind turbines? Wind turbines are mechanical devices that harness the power of wind to carry out certain tasks. The first wind turbines were actually windmills used to grind grain or pump water. But as time has worn on and technology has advanced, we use them to generate electricity. So how do wind turbines do this? A figure from Mechanical Engineering Online, as can be seen at the right, helps demonstrate this process. As wind passes by the turbine blades, it causes them to rotate. This rotation spins a drive shaft hooked up to a generator, which converts this mechanical energy to electricity. The design criteria that maximize the generation of electricity, are aerodynamic efficiency, wind interaction, and adjustment for changing winds. According to alternative energy tutorials, aerodynamic efficiency helps increase overall efficiency of our turbine. Three factors affecting aerodynamic efficiency are blade design, number of blades, and blade length. Blade design can maximize the lift force that wind generates on our blades, which is directly responsible for the rotation of our turbine. As you add more blades, efficiency increases. However, beyond 3 blades, the gain is marginal and is often outweighed by the cost of the extra materials. Increasing blade length increases the area our turbine sweeps through, which is directly proportional to the power output of our turbine. However, if the blades are too long, you begin to sacrifice durability. Our second design criteria is wind interaction. Wind speeds must be high enough to generate a lift force that will rotate our turbine. According to learnengineering.org and the picture that can be seen on the right, as you increase elevation, winds become faster, so we must make our turbine as tall as we can to interact with strong winds, but short enough to maintain durability and keep costs to a minimum. Our last design is the ability to adjust to changing winds. Wind is hardly ever blowing in a constant direction at a constant speed, so our wind turbines must be able to adjust for these changing winds. Learn Engineering says the best way to account for changing winds is to allow our turbine to rotate about its axis so that it may constantly face the wind even as it's changing. In addition to that, allowing blades to rotate upon their axis increases their wind interaction. Though wind turbines are a form of green energy, they do come with their environmental impacts. According to the article Environmental Issues Associated with Wind Energy, turbines can cause decreases in local bird populations, deforestation, and soil erosion, among other things. The global impact from turbines can be seen as this technology has spread wide and far. The graph below shows that a number of European countries draw a fair amount of their energy supply from turbines. Economically, wind is much cheaper than gas. However, to build a wind farm can cost upwards of $1.75 billion, and wind can sometimes be scarce. But turbines do have a positive economic effect by generating over 1 million jobs throughout the world. Hopefully, you now have a better understanding of wind turbines, the design criteria that make them successful, as well as their global, economic, and environmental impact. Wind turbines have their pros and cons, but it's up to us as scientists and engineers to decide the future of these resources and how big a role they will play in energy production.